Hello, everybody. Welcome to this Climate Now Live here on Euronews YouTube channel. My name is Jeremy Wilkes, and we're asking today, what's happening to the water cycle as the planet warms? We hear from scientists that we should expect more extremes with climate change, more flooding, more droughts. So what's really happening and why, and how should we adapt? And looking back at last year, we've got the latest data from the Copernicus Climate Change Service, which we're going to be going through today, looking at some of the extremes that we all lived through. But let's introduce our guests who are here to take your questions, actually. So please do write those questions in the chat, send them to us on social media using the hashtag Climate Now. So let's welcome Samantha Burgess, the Deputy Director of the Copernicus Climate Change Service. Hello, Sam. Hello. Florence Habets, a hydrogeologist from the Institut Pierre-Simon Laplace and CNRS. René Orth. Hello, René Orth, an expert in soil moisture, vegetation and climate feedbacks from the Max-Planck Institute for Biogeochemistry. Hello, René.
Hello, everyone.
Christel Prudhomme, the leader of the environmental forecast team at ECMWF, the European Centre for Medium Range Weather Forecasts. Thanks for being with us, Christel.
Hello.
And Andrea Toreti, a senior scientist at the European Commission's Joint Research Centre and a coordinator of the European Drought Observatory. Thanks very much for being with us, all of you. As I said, please send us your questions, because we know that the questions around water are in everybody's minds now. We've seen conflict and confrontation. We see new rules coming in, changes in how water is managed in our environments, in our villages and cities and towns. We know also that last year we had heat waves and droughts that impacted agriculture, industry, river transport, etc. But I just want to start really with a personal note. Let's start with Sam. Are there changes in the water cycle that you have felt personally, that you feel that you've kind of witnessed? Has something happened really where you thought, that didn't used to happen before?
Yes, definitely. I think alongside temperature changes, so gardens and plants flowering at different times of year, you notice the grass going brown much earlier than it used to. So I think people are a lot more conscious now of changes in the world around them due to climate change.
Andrea, can I come to you?
Yes, also I have been experiencing the lack of precipitation, for instance, last year and this year as well, because I live in northern Italy. Is one of the region that has been most affected by the last year drought and also by the lack of precipitation in this winter.
Yes, it was pretty harsh, wasn't it? And those satellite pictures from the Po Valley were pretty shocking that we saw last year. Florence, how do you feel that you've been impacted?
Yes, well, actually in France, we have this big drought with a lot of cities missing drinking water. There was some fire even in northern France, in Brittany last year. So it was really something that was kind of forecast, but still it's hard to see how fast it's arriving.
Yeah, René?
Yes, also for me, since this 2018 drought in Central Europe, I think I can also feel it more. I mean, it starts in my garden where we have a water tank to collect the rainwater that we use in the garden during summer. And that water tank is not sufficient anymore. So we needed to buy a second one to be able to water the garden all summer. But then also you can see it in the surrounding. We start to have wildfires in our region in central Germany, which I cannot remember that has happened before. And also for agriculture, it's getting more of a problem.
Yeah, absolutely. And Christel?
Well, I'm originally from the south of France, and I moved in the UK 25 years ago, and it was much wetter and grayer and miserable than I was used to. But what I've noticed with the years coming, and now, like Sam said, as the spring starts much earlier, you've got very warm days. I can't remember any of those warm days when I moved in, 20 years ago, and now they're quite regular. So it's a big change.
Climate change even made it to Reading. No, it's true. People are starting to feel impacts, and it's great that people are sending us questions already. And in fact, one of them I think plays into what we're trying to do with this live and with the Climate Now show in general. They're asking in what ways can we fully inform the public about climate change and other dangers? And I would say that obviously have a look at euronews.com/climate now, search around online, but go to reputable sources and try and inform yourself about what's happening. And I think it's really helpful to look at data. So let's have a look at what happened last year, because we know it was hot and it was dry in a lot of places. If we can just bring up the first graph, it shows the seasonal precipitation anomalies for 2022. Sam, can you just talk us through what we can see here?
Yes, so the four graphs that you can see here cover winter, spring, summer, and autumn. And the brown colors on this graph show a lack of rainfall or precipitation, and the greener colors show surplus or additional rainfall or precipitation from the average. So you can see by and large most of Europe is brown for each of those seasons, and particularly in areas like Spain and France, you can see that it is very dark brown for the majority of the seasons.
Particularly, but then for winter, and that's a bit of a surprise when I see that. Andrea, is this happening again now this year already?
Yes, yeah, indeed. This year we have seen a winter that in some regions of Europe is really similar to the 2022, and also, for instance, in terms of snowfall accumulation, it's even worse when we look at the Alps, and now again we have an occurrence of early heat waves, for instance, in Spain, something that also last year happened. It was around mid-May.
So you've got a heat wave there already happening in Spain.
Yes.
What's happening there related to the water cycle? Because I guess you can have a heat wave and not necessarily have a change in the water, right?
No, of course, what is really, let's say, making the impacts heavier is the combination of the two. You have a drought event evolving, and then it comes, spring, May, and it starts with these early heat waves, and then you go into the summer. And last year, if we see, for instance, the evolution of the 2022, so we had then a sequence of heat waves that indeed contributed to exacerbate the impacts of the drought event.
So do you think 2023 is going to look a lot like 2022 actually already, or that at least, what we just looked at the seasonal figures and we saw how winter was dry, the same thing has basically happened again?
At the moment, yes. Yeah. If we see the evolution of the last months, it really resembles the 2022.
Florence, is this just a Southern European problem, or is this happening everywhere?
Well, it's so far it's mostly a Mediterranean problem, because hopefully we had rain in the northern France at least, and I guess in northern Europe. But yes, the problem in the south of Europe is that as it's a long drought, there is more problem because the groundwater and the reservoir are not full, and so it's increased again the problem for the people who live there.
René, you're an expert in plants and the interaction between soil moisture of the plants and these changes in the climate. What can you just talk us through what we're seeing happening? What's the kind of situation at the moment in the last couple of years?
I think the situation is that the vegetation increasingly suffers from a water limitation. I mean, in Europe, actually, we have the natural long-term situation would be that in the south of Europe, vegetation is more limited by water, and in the center and in the north, it's predominantly limited by energy supply, so by temperature, radiation. And what we're seeing is a change there. So the water limitation is expanding from the south to the center of Europe. So it's expanding in space, but it's also expanding in time. So the season during which vegetation is water limited, for example, in Southern Europe, as Florence was saying, is expanding.
What does that really mean for agriculture? I mean, what are the kind of implications of that? I mean, a couple of bad years, but what does it really mean?
I think for agriculture, it means that water supply is becoming a problem. Used to be a problem before. So some regions may need to think about irrigation infrastructure where it was not needed beforehand. Another way to adapt could also be to change the timing of crops. So to not be in a season with too high temperatures or too strong radiation, so basically too strong water demand. But then again, if you do such shifts in timing, you have to go more to the shoulder season, so maybe to earlier spring, and then you're more endangered by a spring frost. So it's kind of, there's no easy solution to that.
There's no obvious kind of adaptation. Christel, floods. We keep telling people that they should expect more extremes. We've already just talked about drought, and drought is what's in everybody's mind, and it has been what's in everybody's mind. Why aren't we seeing floods at the moment? Is the prediction that we're going to have more floods and more intense floods actually not necessarily coming true at the moment? Is there something we don't understand?
I think flood, it's much more variable. It always had flooded, but what's happening is that it's much more difficult to predict, and you've got it short event. It don't last very long, but they do continue happening and quite regularly, and it's kind of a devastation. And one thing that I've learned in the UK is you can have a drought and a flood at the same time, nearly. You can have a very long period of drought, and then suddenly an outburst of rainfall, and nobody is prepared for that. But it will not stop the drought, and this is what is the worst in terms of communication to the public.
How does it not stop the drought then?
Because the rainfall just don't go to the ground, doesn't go to the soil, doesn't go to the aquifers, goes very quickly into the rivers, bursts the banks of the river. We can't do anything with the water there. And then it's gone into the sea. And the drought remains because you didn't have this magic, what we call the recharge, the water going down into the ground and making the soil and the aquifer wet.
Is that because the soil was already kind of dry and hard and not ready to absorb then?
It could be because of that. It could be also because of the intensity of the rainfall. If it goes too fast, the rainfall, you've got too much rainfall, it can't go down into the soil. A good rainfall to stop drought is when it drizzles for a long time.
Right.
And then it can go slowly infiltrate in the soil. You've got a big thunderstorms. Everybody will have experienced that. A big thunderstorm, and you've got water kind of running into the hills, into the streets.
Yeah, and we saw footage from London being completely flooded by heavy rain like that in the last couple of years, where it was going down into the underground and everything, and those are quite shocking scenes. Is that climate change doing that?
It is consistent with the science of climate change and with warmer temperature. Yes. Now I don't know how to attribute one event to climate change. And you had very big flood and thunderstorms in the past, I'm sure. But the fact that you've got warmer air, you've got more moisture in the atmosphere, you can have those bursts of rainfall that were more typical from Southern Europe, and they're moving up Northern Europe.
But I don't know who's the best to answer this one, but how do you adapt to that? If that's the sort of new model, then what do you need to do in order to capture that water and to use it actually to your advantage?
Maybe I can say that so there are different ways, and adaptation. When it comes to adaptation, actually it works only if you address the different spatio-temporal scales, because for sure you need to develop sectoral specific adaptation strategies that are targeting really the needs of specific sectors, and then you have also a regional and a national and a European scale, and these must go all together. And of course this means enhanced cooperation, but also it goes through the development and the availability of early warning systems that can really, and climate services that can really inform and translate data into actionable information.
What kind of things are we talking about building on the ground then, when you say adaptation to try and use this water? Are you talking about really making infrastructure changes?
I mean, there are several different approaches. For instance, if we look at sectors such as agriculture, one of the adaptation strategies that really can work is, for instance, integrating existing decision supporting system with climate services that can inform early in advance on the risk that basically the crop can feel in well ahead in the season. Because if you have such a mechanism in place, and together with an economic mechanism that can really stabilize, then we have already proved that it can reduce a lot the impacts and the risk connected with climate extremes.
René, can I bring in you on this one? If this future that we're going into involves these long periods of warm, dry weather, and then occasional sporadic massive downpours, how are we going to manage that best?
Yeah, I just wanted to add to what Andrea was saying, because I think we can also respond to that not only with infrastructural changes and with early warning, which certainly are important measures to do, but also how we manage our land and how we do our agriculture can help. For example, a forest can better save water because soils are typically deeper, roots are deeper than bare land can.
So plant more trees is your solution. Well, but what about yeah, go on.
Yeah, indeed, reforestation would help to keep more waters.
And green spaces in cities as well, slowing down rivers. So there's a lot of nature-based solutions to really keep the water in the landscape rather than let it run out to sea or run out to stormwater.
Florence?
Yes, nature-based solution, I guess it's a good way to do it, because it can help for flood and for drought. So, and sometimes it can support some the uncertainty we still have on climate change. So this is always something good to do. And as would say, no artificialization, more trees, agroforestry, for instance, are good solution.
What would be the typical changes then that you might implement, for example, in the UK? We're talking about it happening there, or in northern France, like concretely on the ground. What would you do to try and keep that water back, slow it down, etc.? Planting trees is one of them. Is it building more floodplains? What do you do? So
yes, they can change actually the surface. They can have for instance, sidewalk with something else than concrete. There is a lot of work on the school, for instance, to have places for the children with trees instead of concrete. And also there is this rules to have to go for the no more artificialization. This is in the law, but of course it is hard to reach. What
else can you do? Is that it? Kind of basically plant trees,
yes, and then
try not to put down too much concrete.
Yes, then the good thing, as Christel said, is to increase the recharge to the soil and to the groundwater. And so far, what we see is that the land use has changed and has somehow decreased the possibility for the water to reach the groundwater. So yes, if you keep some places where the water can actually slowly infiltrate to the soil, so some small wetlands, let's say. So this will be good. And for years, the wetland has disappeared because we have built on it. So now it's time to take care of the natural network and to go back to the natural ability for the environment to store the water.
I want to carry on the discussion about this topic, but I also want to have another look at one of the other graphs that came out last week, which is showing the wet days anomaly for Europe in 2022. And I think this is interesting because a lot of the people who are watching us live somewhere on that map, and they will say, okay, it was wetter or drier where I live. But I'm looking at that and I'm thinking, what happened in Poland? We know it was drier in Italy. What happened there? What happened in Poland? Sam?
Yeah, so the wet days anomaly is basically looking at whether in a 24-hour period there has been rainfall or precipitation of more than 1 millimeter. So what you can see in this map is large areas of red, particularly in Poland, as you mentioned, but also Italy, France, northern Spain, and parts of the UK and Ireland, where all the colours are either orange or red. So it's really showing, as we've already discussed in the conversation so far, that the gentle rain that is what's needed to recharge the landscape is less frequent than it used to be. And we have these intense, heavy precipitation events which run off. So there's few intense events and less of this gentle drizzle that many people who live in Britain are intimately familiar with, or used to be, and that's happening a lot less frequently than it used to.
So that's interesting. And that's pretty much everywhere, actually. Pretty much everywhere across all of Europe is having that same issue.
Yeah, it was a large-scale phenomenon last year. And I think one thing that we haven't touched on yet is that these factors are very cumulative. So we know last year for Europe was the second warmest year on record. It was the warmest summer on record. So these hot temperatures combined with the dry conditions, combined with the wildfires that we saw last year, they all interact with each other. So when we have higher temperatures, soil moisture dries out more, which leads to precursor conditions which enable more wildfires, which increases the drought conditions more, because when you have a fire go through the landscape, it dries everything out even further.
So we're not getting these drizzly days that I remember from my youth growing up in Wales so much as we were. And when I started out covering climate change issues in a very general way, maybe about 15 years ago, I remember climate scientists telling me that basically what they expected to happen in Europe is that it would be much drier in the south of Europe and it might actually get wetter in northern Europe. That doesn't seem to be happening.
Yeah, so I think that is still the forecast, and that's certainly what the IPCC report, the sixth assessment report, has come out and said recently. So one of the big challenges with what we've seen this winter and also last winter is the recharge period, particularly for the Mediterranean, is in the autumn and the winter and the spring. So when we don't get that rainfall in those seasons, there's not likely to be any rainfall in the summer. We also know from climate projections that summers are going to get hotter and drier in the Mediterranean region. So they're really reliant on the rainfall and the snowfall in the mountains to really recharge the reservoirs and the rivers. We also know from science and from the IPCC that we will get more frequent storms in the northern countries. Sorry, I'm going to stop there because my child's interrupting.
Your little voice just popped up in the background there. We thought that might happen, and there he is. It's always nice, though. Has anybody else got any thoughts on this? Because, like I say, I mean, as a journalist, I'm looking at it going, hang on a minute, that isn't what the scientists told me was going to happen. But maybe 2022 was an anomaly.
I wanted to add to this, because I think Samantha has made an important point, which is that the water cycle is connected with the energy cycle. So that means climate change is not only temperature. If temperatures rise, it means also that evaporative demand, so kind of dryness of the air, increases, which increases evapotranspiration, which dries out the land. So this is really tightly connected. So we cannot talk about the water cycle independent of changes in temperature and changes in other climate variables.
I think it's probably a good time to bring up our graph actually on evaporative stress, and you can talk us through that one, René. It's almost like you were ready for that one, and we didn't rehearse that at all. But tell us about what we can see here, because I can just see an awful lot of red where it looks like it was probably hot. But what is this evaporative stress index? This is related to vegetation, plants, and soil moisture. Can you just explain what we got here?
Yeah, maybe first to set the stage, one of the problems that we have in water cycle research and water cycle understanding is that some of the key variables of the water cycle are actually poorly observed. So for example, soil moisture, we can model it, we can observe it with a satellite, at least in the upper few centimeters of the soil, but there's uncertainties in what happens in the deeper soil. Same for evapotranspiration. Now getting to this figure is another essential quantity of the water cycle, but we can only measure it very well at a few stations, and it's not really possible to accurately observe it from satellites. So what this map is showing is actually a new product and kind of an advance in observing evapotranspiration at large spatial scales. What they do with these satellites is they observe land surface temperature. So basically the temperature of vegetation and soil surfaces. And this temperature tends to scale with evapotranspiration, because if evaporation is happening, then it cools the surface. And that's why they can relate that signal to actual evapotranspiration. So they use this land surface temperature satellite signal to compute this evaporative stress index. And what this is basically telling us, yeah, as you were saying, there's a lot of red, which means enhanced evaporation. So enhanced evaporative demand is a result of higher temperatures. Because when temperature is higher...
Does this mean basically that the plants are getting hot and they're sucking up a lot of water, and that's what's going on, and you're taking even more water out of the soil? Is that it?
Yes, partly. Even though, first of all, I think is the air is getting hot, and when the air is hotter, it can take up more water and will soak up more water from vegetation and from soils. That's the one thing that happens. And the other thing that happens is vegetation is smart. Vegetation can respond to an increased evaporative demand. It can close its stomata. It will turn down its photosynthesis and save water. But also this is only possible to a certain extent. And when we observe this evaporative stress index, it's basically a sign that we're pushing the vegetation to its limit with this mechanism.
What should we do then in response to that?
Yeah, that relates back to the previous point when we talked about specific measures like having more green in our cities, and maybe also thinking about ways how we can adapt our agriculture. For this, one point I think is good to add is maybe for us, it's good to also inform the practitioners, which maybe locally know better than us what might be the best solution for their city, for their agricultural field. So I think already informing and doing debates like today to explain to people how things work together is an important first step.
Yeah. Anybody else like to contribute on this? Because it seems like it's a complicated system with a lot of feedbacks in it, and it's what I think was interesting, what René was talking about, is the fact that we don't have an awful lot of information.
Yeah, I mean, this is indeed one of the challenge when it comes also to evapotranspiration, because as we have seen also last year, what we do often, we use what is called potential evapotranspiration, assuming that there will be enough water. But of course, when there is an extreme drought going on, this is not the case. And in terms of adaptation, as also René said, so we need to go really local, and that's why now also at the European level there are initiatives such as the Mission Adaptation that are really trying to develop things with the local communities and see what their needs and how we can really push adaptation in a sustainable way, of course, because from one side it has to be effective, but on the other side it has to be sustainable. And so
can you give me some examples on the sorts of things that a local community might do?
Well, there are several examples. For instance, if we look at specific regions of Europe, the communities can avoid water competition by, developing, for instance, different agro management strategies when it comes to the use of water. This is, for instance, the case of rice sector, that in the last year they have been discussing how to use water in a different way and move away from, flooding, keep the rice field completely flat, and then to avoid the competition with, for instance, grain maize that is cultivated in the same region. So this is like already an example of the cooperation at the local scale and trying to enhance adaptation and resilience.
One of the questions we've just had actually kind of, I think, ties into what's in my mind listening to you, which is asking about what are the best strategies for addressing climate change? What are the key elements of a successful collaboration model between stakeholders on handling climate change? What you're talking about there is a bit of a concrete example. You've got the guys who are making maize, and of course then they're using that to feed livestock that eventually turn into food. And then you've got rice, which is, we know, of kind of great cultural significance in certain parts of Europe as well. All of those competing for water. Some people would argue you shouldn't really be growing either of those crops in Europe because they're too hungry for water. How do you create a good collaboration between people on this and hammer home the message that water is not infinite? You can't just use as much as you like.
I think, I mean, this has been highlighted very well at the UN Water Conference. So that there is a water crisis, and we need to inform and make all people aware that we cannot keep using water as we were doing in the past. So that's quite simple. And there is a need for cooperation, and cooperation at the level of the different sectors, but also at between countries and at the global scale. So this has been one of the main outcomes of the UN water. So without cooperation, we cannot really solve the water crisis.
But how do you overcome conflicts? Maybe somebody else has got some experience on this, but how do you overcome conflicts and competition? Because, you know, somewhere like the Po Valley or somewhere like the Ebro Delta, there's a lot of people who want that water. Florence?
So in France, there is some limitation by law, right? When the situation is too tough and when there is a drought, there is some restriction of the water usage. So first for instance, to wash the car, something very small, and then if it's become more problematic, there is some limitation for irrigation. But of course, there is some derogation. But yes, somehow the state is trying to decide with consultation, also with the public, how to do it, and this is a good issue, a strong issue. And I just want to mention that there is also an issue with the biodiversity, right? Of course, the fish has to be taken into account. They are the first one to suffer when there is no more water in the river. So, of course, in Europe, there is this Water Framework Directive that says biodiversity is also has also a right to have water.
A couple of questions in my mind, actually. One, I was thinking earlier, you know, you have these hosepipe bans, you're not allowed to wash your car or whatever. Has anybody actually studied how effective those are? Are they actually measures that really actually make a difference to the availability of water for the other users, or are they just something everybody does to make themselves feel a bit better?
I can say something about France, because we have this big drought in 2022, and we have a return of experiment about this drought. So, for instance, if you go to an establishment will allow you to wash the car, it has to be closed at that time. So this is okay. But if you do it by yourself in your garden, so you are not controlled. And so yes, but that was the point. They said one of the results is as we do not know really how much water we pumped, we abstract, so we cannot know if the restrictions are effective. So first thing is to actually monitor the abstraction of water, the water usage.
Sorry.
Just for this, I wanted to quickly add, I've recently read an article about that in a district close by my home city. They also implemented restrictions for water use since actually 2018, that for private people, they should not use it to water their lawn or to wash their cars. And the way they monitor that is they look at the groundwater level. And as they saw, now the groundwater level is going to back up to what it was before 2018. They relax these restrictions again. But what they don't know is if the groundwater level is just going back up because it has rained a lot recently, or because really the restrictions were very effective. Yeah.
So in fact, there's a lot of mystery there about where the water's coming from and where it's going to. We've got this regulation coming in from the European Commission in the summer this year on reuse of water which has been treated, but it's water from urban areas that can be used for irrigation. Does anybody on the panel actually think that that's going to be a really helpful measure that could actually start to make a difference? Because it's from this water directive. It's coming into force at the end of June, I believe, and it's setting lower limits on the amount of use. Certain countries are very bad at it. I know that France is bad at it, and I think Italy's a little bit better. But using that urban water for something else afterwards, rather than throwing it into the sea, which is what often happens.
Yeah, so the use of grey water is really important, and there are many countries around the world that have done this for a long time. And you see people running pipes out of their washing machines to water their garden with washing machine water. And obviously, you can't use all urban water, but it's a really important use of recycling water, and we all need to be better at that.
How do we, as a society, move in that direction? Because I think people are going to, if you're committed and you're keen and you're interested, you're going to do that. But it's a massive infrastructure change, isn't it? If you want to actually try and make that happen on the scale of a whole city or a town or whatever.
So I can start on that. I think there are a number of measures, and really it's about education and changing the way that we treat water as a precious finite resource. And I think in the past, particularly in Northern European countries, there wasn't this expectation or understanding that water was a finite resource. So it was treated as something that you could use at your leisure. And we certainly have a lot of infrastructure with leaky pipes, Victorian infrastructure that leaks a lot of water away. We have a lot of hard substrates, as we've already discussed, which let runoff go straight into stormwater or out to sea. So it's really changing the structures and the infrastructure in cities where we're based. And one of the things that I'm aware of in the UK, at least, is planning permission for houses. You have to prove that you're not changing the substrate too much. And there's parking is obviously a premium in many cities, and there's a big pushback for people providing parking and making it a hard substrate, instead using gravel or a permeable surface, so that water, when it does rain, where you park your car, it falls into the ground and gets soaked up by the ground rather than runs off in drains. So there's lots of little measures like that. Obviously, food's a big issue as well. We've talked about agriculture, so really looking at the water content of what we're eating and adapting accordingly.
It does sound, though, that we are maybe going to be fighting a losing battle. I mean, Andrea started out the conversation, we were talking about how the situation with the amount of drought that we've got now. How radical are the changes, Andrea, that you think we need to bring in order to actually cope with these changes in the water cycle, particularly related to drought?
I mean, it depends a lot on the other side of, let's say, of the problem, because from one side we have adaptation and the efforts we do with adaptation, but then we have also mitigation. So it depends a lot also on the efforts we put on mitigation at the global scale, because of course, when it comes to mitigation, it's not just a matter of a single country or of Europe. It's a matter of a global effort to really keep the warming level as much as possible below threshold that indeed make possible to adapt, and to also have an adaptation that can be effective and sustainable. And so this is, I think, so we need to combine both. We cannot just look at adaptation. So we need to look at the two together.
Yeah, absolutely. But we certainly need to put a big focus on the adaptation.
Yes.
I think it's certainly that's my feeling that I'm getting from covering these stories over the last few years. I want to have a look at one of the other graphs that we had prepared for this, because I think it's, again, it's fascinating to look at the data and to look at maps and to understand what's happening on a European level. Let's have a look at the map for river discharge for August last year. I think it gives you an idea of the situation related to the drought and the impacts that had. We reported in our Climate Now program on Euronews about how river transport, for example, in Germany was suffering. Christel, do you want to talk us through this and what we can see here?
Yes, so all the shaded colors of red and pink means that the river discharge is below the average, and the darker the color, the less water you've got in rivers. And what you notice is that it's pretty much everywhere in Europe has below average. And as you mentioned, that has implications in terms of transportation. And in fact, during 2022, more than 10 months had below average river discharge, which is quite phenomenal, because normally what you expect is kind of seasonal variation and kind of some months where you've got the higher than average flow and months with lower than average flow. And here it was pretty much the whole year. And with we mentioned with less river discharge, you've got less water for irrigation, less water for transportation, but less chances for pollution as well. More chances, for pollution, more chances for, in the summer, the water becoming warm and too warm for some of the ecosystems. So all that, we mentioned the feedback and the kind of complexity of things, it makes the situation pretty grim.
It is. You work on giving authorities warnings, I suppose, I think you'd call them, or just heads up on what's happening. Do you want to talk us through a little bit about what you do? Because it's fascinating. When you showed me the other week, I thought it was great. So just talk us through a little bit about what you do, because not everybody might be aware of this, but go on.
No, so we talked a little bit about adaptation, and I'm going to share my screen. There are kind of tools, kind of like long-term adaptations, but there is also things which are prevention and early warning, and I think Andrea mentioned that. And what we're doing, and this is a Copernicus a service from the Copernicus Emergency Management Service that put warning to authorities which are allowed to issue warnings on flooding. And I wanted to show you what happened actually in 2022. So it's something that is not open to the public. It's only opened to eligible organizations, but for the public, you can have information about what happens more than 30 days ago. So let's go now. I'm going to the 16th of November. And we did say that, the whole of the summer was pretty dry. And here, what this map shows, it's episodes of flood. And that will be available to all the partners that have access. And if you zoom in, let's try to zoom in to a region. Let's zoom into southern Italy, because actually something happened in southern Italy in November. A quite damaging flood happened on that little island, which is too small for our system to be able to model and forecast. But you can see colors red and purple. That means that there is a quite high chance for the river flows to be kind of at a flood level. And if it's red, it means that it's quite a lot of chance to be at a level of flood which is expected only once every 5 years. And you click on that point, and what you see, we're here the 16th of November when we made that calculation. And what it was saying is that you might have two floods coming up in the future, around the 19th or the 22nd, 23rd of November. And in fact, they had a big flood the 22nd of November. So you could have some early warning telling you that something is going to happen. I'm going through time now. And you can prepare the community. You've got time to have this information. And the more the closer you are from the event, the more defined and less uncertain you've got on when it's going to happen and how it's going to happen.
You can do the same kind of thing you're doing the same sort of thing for droughts as well, are you, for low river situations?
So for low river, what we do is we produce those information. I'm going to stop the screen. We show this information in the form of those maps. So we produce at the moment the maps once a year for the European State of the Climate. But with Andrea, we're hoping to be able to do the same sort of maps every month, to have a retrospective of last month or the last few months. And then we'll also, we send all this information to Andrea's team, and then he's looking at how that can translate into droughts with the European Drought Observatory.
So somebody who is on the receiving end of that, I'm guessing this is a local authority, some kind of decision maker. Andrea, can you talk us through what they would do then? They got this forecast, which is very helpful. In the past, you wouldn't have known that you're going to have a particular flooding risk, though that many days ahead. What are they going to do?
Well, I mean, it depends, of course, if the risk is about flooding or drought.
Yeah.
When it comes to flooding, of course, then to floods, the civil protection can activate measures to indeed reduce the expected impacts. When it comes to drought, also, the countries have different management plans, and at the moment, indeed, what we are doing is we are trying to review the existing drought management plans, because respect to flood, the situation is more heterogeneous in the European Union, and thanks to a project that is called EDORA, we are now indeed reviewing what is happening in all the European countries and trying to indeed make possible learning from each other and take the good examples from one to the other and trying to enhance the management plans with respect to drought. And we also have established a group with all the member states that is really looking at water scarcity and drought.
Another thing which I think which we haven't talked about much so far, but part of the water cycle obviously is the snow also, which one would hope you were going to get on the Alps, which we didn't see in 2022. And there's a really interesting map that's produced from the Copernicus State of the Climate report last week that shows the number of snow days anomaly, and a lot of people know it didn't snow that much in the Alps, but in fact when you look at this you realize how much it didn't snow compared to average across a large part of Germany there as well. This is again part of the water cycle. Can somebody explain what's going on here? What's happened? Does it mean there was no precipitation? Does it just mean there was no snow? What happened?
So for number of snow days and having the oranges and reds to say that there was no snow or much less snow than average, it means the temperatures were so warm that it wasn't possible for precipitation to fall as snow, and
Right.
instead it fell as rain. So this impacts how much water you have in the environment. It impacts snow, obviously, in mountainous regions. It impacts glaciers as well. So there are a lot of repercussions from this reduction in snow days that we've seen across large parts of Europe, except for, of course, Scandinavia, where in 2022, and particularly the winter of 21-22, there were some small glacier growth and a small increase in snow days for that particular region.
But I suppose the important point as well, which relates to the river discharge thing, when I was reporting from the Rhine last year, they were saying that one of the major issues was the lack of snow, because the summer relies on that melt in order to keep the river going, and it wasn't receiving that. And I think some of the figures are pretty scary. Let's have a look at the annual glacier ice mass change that happened last year in 2022. If you saw this one, you'd think there was some kind of mistake. That's how bad it looks. So if you look on the mass change on the bottom there for 2022, you can see how serious it was. The figures are extremely scary. What's it? Something like the snow and the heat waves, basically the lack of snow, meant that there was a loss of ice of more than 3.5 meters on average across the glaciers in the Alps. If you were to average them out across the whole area, is that climate change, and is that going to happen again?
Climate change is certainly contributing to it, and as already discussed, the warm temperatures in 2022, the lack of rainfall and snowfall, particularly over the winter period, really meant that the snow wasn't there in the winter. And then we had a number of heat waves last year, so it wasn't just anomalously warm over the summer, it was also warm in the spring, in the autumn, and over winter as well. So that led to much higher melt from the glaciers than what we'd seen in the past.
Florence? Oh, we can't hear you for some reason. I don't know why I can't hear you at the moment. Yeah, maybe your microphone is... No, can't hear you now. Okay.
Maybe I can jump in, because I also
go on,
wanted
René.
to add to this point. We were talking before about the different rainfall intensities of having drizzle versus intense rainfall, and how that would differently recharge our groundwater. I think in that direction, we also need to think about snow and glaciers as water storages. So for example, if water falls as snow, when the snow will be melting, that resembles more a drizzling event, and will be much more efficient for groundwater recharge than if the water doesn't fall as snow, but it falls as precipitation. Likewise, the glaciers, when they are kind of melting in summer, as they typically do, they provide a very constant and very modest water supply to those alpine valleys. While when they are shrinking, or when they're disappearing totally, this very constant and reliable water supply that they've had for decades and centuries will be gone, and they will have to adapt to that.
That's interesting what you say about a melting glacier kind of being a little bit like drizzle. I think I won't look at a glacier in the same way ever again after that. But no, it's interesting. I think it's an interesting point about that flow and how much we rely on it, and how much most people don't think about that. They probably just think that the snowy peaks look rather pretty and nice and decorative when you go to the Alps on holiday. A question that we've got coming in, and René, I'd like to hear your thoughts on that. What do you think of George Monbiot's suggestion to change farming radically and only grow crops in labs through bacteria, and stop planting crops in the traditional way?
Yeah, that's a very radical suggestion. I wonder if people would buy that in shops, if they can choose, if you want to have your tomatoes from the actual plant or from a lab. I'm not sure what people would choose.
From a water point of view, a water use point of view, obviously doing it in the lab is going to be more efficient, though, right? But
yes,
not from an energy point of view.
Yes, I mean, we're also growing lots of vegetables in Europe. We are growing them in southern Spain in large greenhouses, which from a water use point of view is not the best thing to do. So yeah, there is some adaptation one can do. The question is if people will accept that.
What would you say would actually be the best approach to evolve the agriculture and the farming and the production? Because we want to be independent. We don't want to be importing food from elsewhere. From your point of view as a scientist, how should we evolve? Should we literally just change the kinds of plants that we're planting? Or what should we do?
I think, again, for this, I would leave it a lot to the practitioners who, with our information, can make the best decisions. Maybe in that direction, something that we can also take care of is again this information component. Maybe that also in supermarkets, people do not only know where where their tomato was grown and if it was grown organically or conventionally, but that they also get some information about the water use that tomato had, and where it had that water use. So making people aware, I think, maybe can already help quite a bit.
That's a fascinating idea. Yeah, absolutely. Although, again, from a marketing point of view, I suppose you could say this was grown using water that rained on a concrete car park somewhere. It's not necessarily going to be easy to sell. But I see your point. The water component in the product that you're buying. Florence, I think you're back with us, and you disappeared from the audio. You're going to make a point about the snowfall.
Yes, actually, it was about the glacier, because the new climate projection state that almost all the glacier in France will disappear at the end of the century. So this is actually a very sad news. It was not expected 20 years ago, and so it's going very fast. And of course, it will impact a lot the water resource in most of France. And so this is very sad.
What can we do to try and adapt to that?
Well, it's a big issue. I think we have to all consider almost all our activities, because, for instance, in France, for the Rhone River, which is the big one close to the Alps, there is a lot of nuclear plant, for instance, that needs a lot of water. So somehow you need to have some priority to the use of water. And perhaps you have to think completely differently, both to mitigate the climate change, because we could not adapt if there is no mitigation. So we have to mitigate, and it's a big issue for the future of our life, and we need to adapt. I guess we cannot be predictive. We cannot say you have to do this, but probably we have to all together decide on priority. And for instance, you were talking about agriculture, but the way we actually need to choose our food is having some impact. For instance, if we need less meat, it will generate some different value. And also there is a point, agriculture is not only food. So don't forget this, agriculture is not only food. For instance, there is a lot of biofuel, agrocarburant, I don't know exactly the word.
Biofuels, yeah.
And it's a big, it's actually big surfaces in Europe.
Which use a lot of water as well. Fundamentally, behind all of this, what's driving the change? Because it's not as if our planet is losing water into space. What's happening actually? Sam, can you explain to us why is it we've ended up in this situation? What are the kind of, is it the weather patterns have changed? Is that it?
So the reality is that Europe is warming faster than anywhere else, any other land area on the planet. So in our report and in the latest data from the World Meteorological Organization, Europe is warming twice as fast as any other continental region. So with those warmer temperatures, it impacts the rainfall patterns, the precipitation patterns, which means that through changes in circulation, instead of rain falling where it used to, it's falling offshore. We have these very natural variability within weather patterns, but climate change and warmer temperatures is really driving weather patterns to change more rapidly than what we've seen in the past. And the only way, as Florence just mentioned, the only way to prevent increased rapid warming is to mitigate, so to stop emissions of greenhouse gases going into the atmosphere.
I just flashed up there rather too early, but the interesting data that you have dating back to 1950, which shows the precipitation anomalies. The one to look at is at the top there. I think that is very interesting and revealing, because we're talking a lot about the drought in 2022, but it looks like it was very dry in the 1950s as well. Can you explain what happened there?
Yeah, so perhaps I can start and then Andrea can complement. So for 2022, it was, we know for soil moisture, it was the second driest year in the last 50 years. So as hopefully people can see watching this, in the left-hand side of the graph, you can see the orange and maroon lines showing precipitation anomalies in the 1950s and 60s. So we know that we've had droughts before in Europe, and many records, not only our records, but other national records around Europe show this variability in precipitation through time. But what was different last year was the combination of the dry periods in addition to the high temperatures.
Sounds like you have a contributing scientist there behind you who's got something to say. Andrea, can I bring you in on this? It doesn't seem like it's a new thing for us to have droughts. Why are we suffering so much now?
But if we look at the spring to summer season, and we look at the combination of precipitation and temperature, we see indeed that what we are experiencing, what we have been experiencing in the last years, is really an emerging pattern. Is really unusual. If we look, for instance, at 2018, so 2018 in Central Europe, the combination of spring and summer temperature and precipitation condition was really extreme. And we estimated by looking at the paleoclimate reconstruction that basically in the last 500 years, where we had the reconstruction available for spring and summer European conditions, so basically there were no other events as severe as the one in 2018. So of course, if we look at the annual timescales, this is slightly different, but what is really, as I said, extreme is now this combination, this compound, and as well as the recurrence.
Yeah, absolutely. So, just a kind of final word, because we've been talking now for an hour, but I think we should probably try and wrap up. But how do you see the water cycle evolving into the future? Can I just get a couple of words? Maybe we'll start with Florence on this one. What do you expect?
I expect to have some variability. Some year will be wet, but somehow there will be some more longer drought. This is something pretty sure, and so we have to help forecasting this drought year and try to use the water when it's available.
Get ready for drought. Christel?
I would agree with Florence. This variability, this is something that seems to have been seen more and more often with this big flood and kind of long drought. One thing that is particularly worrying is winter drought, because as we mentioned, it's where the season where naturally the aquifers get recharged, the soil gets wetter, and that allows the vegetation in the spring go back. And if we're missing that, like we've mentioned with the snow, then we might have like a long-term implication and adaptation of the vegetation, but not in a way we'd like to see.
René?
Yeah, I totally agree with Florence and Christel. One point that I would like to add is that we're talking a lot about precipitation, but drought is not only about thinking about water input, but also think about water output. And this is actually where, with climate change, we're going to see more changes if we trust our climate models. What they are going to tell us, for example, for Europe, is that for the precipitation, there will be trends. The north is getting a bit wetter, south is getting a bit drier, as we discussed before, but those trends are not super significant because of this high variability. Whereas for evaporation, so the water that goes out, the models agree very well that this will increase. So we will lose more water through evaporation simply because it's warmer. There's more energy to evaporate. So that's maybe more the thing that we need to keep in mind, which is not so visible, but which will affect our water resources, such that the droughts that we have seen recently is maybe more approaching the new normal rather than we would get back to the previous conditions in the future.
Andrea?
Yeah, I also want to highlight even more the point of René. It's really the compound effects of heat waves and precipitation deficit. Just for instance, if we think of what happened in China last year, there was a moderate precipitation deficit combined with an extreme heat wave. So this is what we need to expect more happening more and more often in the future.
It is not a great outlook. What would be the adaptation recommendation that you'd leave everybody with to conclude this conversation, Sam? What would be the thing you would say if you as an individual or maybe as an organization, you need to be thinking about this and bringing in this measure to adapt to these changes in the water cycle?
I think from an organizational perspective, as the planet is warming, the normal is shifting. So climate change isn't a future problem, it is a problem for now. And we saw that last summer, we've seen that this winter. So we really need to adapt now to the climate that we're facing now, and that means evolving our infrastructure as well as mitigating our emissions in the future.
And I think we all realized that water is not this infinite, wonderful kind of sort of resource that we can just carry on using as we wish, and we need to look after it and care for it. Obviously, changes are coming in Europe, and hopefully we can start to make a difference. Thanks, everybody, for this conversation. Thanks to Samantha Burgess from the Copernicus Climate Change Service, Florence Habets from the Institut Pierre-Simon Laplace and CNRS, René Orth from the Max-Planck Institute for Biogeochemistry, Christel Prudhomme from ECMWF, and Andrea Toreti from the Joint Research Centre. It's been fantastic talking to you all. Thanks everybody also for the questions. And please head over to euronews.com/climate now, where you can see some of the reports that we make every month about how the planet is warming, how we're adapting, and how we're going to deal with this issue of climate change in the future. I'll see you soon.